سلام علیکم ئەم کاتتان باش بەڕێزان لە چاپتەرێکی نوێ پێتان گەیشتمەوە ئەلحەمدوللیلا لەگەڵتانم بۆ تاوکردنی بابەتەکانی کیمیایی پۆلی 12 سیستەمی ئینگلیزی ئەوڕۆ دەست بە چاپتەری سێم دەکەین وەکو یەکەم وانە chapter 3. This chapter is also about the acids and the bases, but this time we're going to take something new about them in terms of the reaction between them practically, which is called titration, and some important parameter, mainly pH and its family, family of pH. Section 1 in chapter 3, it contains some general calculation about the aqueous solutions of acids and bases. Okay, look, aqueous solutions and the concept of pH. This is totally new idea, the concept of pH for us, new thing I mean. So by the end of this chapter, you will become totally familiar with the term of pH. Okay. Still now we know that acids they provide H3O, and bases they provide OH ion. But you know, they are not the only source for the OH and the H3O, because you know, look, except of the acids and bases, hydronium and hydroxide ion are also provided by the solvent, example water. So now we have two sources of hydronium. One is acid and the other one is water. And we have two sources for hydroxide. One is base and the other one is water. Hopefully you remember. Water is amphoteric. It can behave as both acid and base. Mainly it contains a proton and hydroxide ion. Okay, so by changing a small thing about it, we can get both ions, H3O and OH. Okay, so the point is, H3O is provided by acid and water. OH is provided by base and water. So now we have two sources for H3O, acid and water, two sources for OH, base and water. Good. Let's see how to get the hydronium and hydroxide ion from water as a solvent. There's a special process which is called self-ionization of water. What? Self-ionization of water. How to write the ionization of water? Okay, if I ask, okay, how to write the ionization of H2O? Ionization needs to have a solvent as water. Okay, you should know that water is a weak electrolyte, so use the reversible arrow. How to write the ionization of water? Water plus water. To have the ionization for anything, you need to add water. Even if we have water, we should add water, okay? Look, transfer a proton from this to this or this to this, doesn't make any difference, to get the ions of H3O and the OH. Good. This process is called self-ionization of water. It means water ionizes itself to get the hydronium and hydroxide. Now, instead of H2O plus H2O, you can say two H2O molecules to form H3O and the OH. It looks familiar, right? This is you should know this is an opposite process to the neutralization. The one in chapter 2, neutralization, it was the reaction between hydronium and hydroxide to get two water molecules, but the reverse process of the neutralization is called self-ionization of water. Good. What is the self-ionization of water? Two water molecules produce hydronium and hydroxide ion by transferring a proton. One proton. It means one proton. Good. Water in this reaction acts as amphoteric. It can be both proton donor and acceptor. So what is H2O in the self-ionization of water? This is amphoteric. Amphoteric, because H2O in one of them acts as the acceptor and the other one as the donor. We have some general notes about the the concentration of hydronium and hydroxide and ionization of water. You should know this part is very important, so please be careful about these notes. The most commonly used unit for molarity is mole per liter, can be represented by two big parentheses, two big brackets. So once you see two big brackets like this, it means the molar concentration. Example, HCl equals to 1. You should know that this is a molar concentration. So 1 molar, okay? Concentration of hydrochloric acid is 1 molar. The two big brackets, they stand for the molar concentration. Pure water contains, as you remember, the self-ionization of water is like this, H2O plus H2O to get H3O plus by OH. The reversible arrow indicates that the one beside of water next to water is a weak electrolyte. So the weak electrolyte remains throughout the solution beside of the cation and anion. So pure water contains cation and anion with the molecule of water. أنا باسكت دكات خوي لشابتري كم ودوم. So تصاوري ما خليه يدو بارا وايس كم هو شبابي من. In pure water, always the molar concentration of hydronium equals to the molar concentration of hydroxide in any temperature. This is true for any temperature because water is a neutral substance. What is water? Acid or base or neutral? Water is a neutral substance. Neutral substance. In any neutral, hydronium concentration equals to the hydroxide ion concentration. Good. Point number 4. At 25 Celsius degree, again, H3O and OH, they're equal in pure water, and you should know both are equal to this number, 1 times 10 to negative 3 molar. So they're always the same in pure water, but this number stands for 25 Celsius degree. Stands for what? 25 Celsius degree. Let's repeat the rest of the points. The unit of molarity represented by two big brackets. Pure water contains H3O, OH, and H2O itself. Pure water is a neutral substance, therefore it contains equal amounts of hydronium and hydroxide ion at any temperature. At 25 Celsius degree, both are equal, and they have this value, which is 1 times 10 to negative 7 molar. Good. Pure water is an extremely weak electrolyte, of course. Try to highlight this parameter Kw. This is a very important parameter. You know, we will need this, but we will need this extremely. Okay, this is an extremely important parameter about water and the other calculations. So my dear, Kw. What is Kw? First of all, K, it means ionization constant. Because we have in chapter 6, we will have some more K values. Example Ka, example Kb. Okay, look, the water Kw, water ionization constant. Ka, acid ionization constant. Kb, base ionization constant. So be careful about these values of K. Okay, look, water ionization constant is represented by this formula. Memorize this formula right now with me. What is Kw? Kw equals to hydronium concentration times hydroxide concentration. Okay? Hydronium concentration times hydroxide concentration. Okay? Hydronium concentration times hydroxide concentration. Be careful about this rule. This rule is applicable at any temperature. At any temperature and in any aqueous solution. No matter if it's neutral or acid or base. Yalla, لەگەڵم برێوە دەی. KW H3O times OH. This is used at what temperature? At any temperature. At what temperature? Any temperature. For what kind of solution? For the neutral for the acidic solution and for the basic alkaline solution. هر solution ئاوی تێدا بەکارهاتبی. Any water-based solution, okay, can any water-based solution obey this rule, which is KW. So this rule is applicable for all water-based solution. I mean all aqueous mediums, no matter if the aqueous medium is acidic or basic or neutral. Okay, good. Yalla, one more thing. As I said, KW equals to H3O times by OH. Good. This is for any temperature in any aqueous solution, acid, neutral, and base. Good. How about at 25 Celsius degree? At 25 Celsius degree, you should remember KW equals to H3O at 25 Celsius degree is this number 1 times 10. Where? At 25 Celsius degree, H3O equals to 1 times 10 to negative 7 times OH is the same also 1 times 10 to the power negative 7. So KW equals to 1 times 10 to the power negative 14. KW has this value at 25 Celsius degree. So if I say this rule is used for what temperature? For any temperature. How about this? KW equals to H3O times OH equals to 1 times 10 to negative 14. How about this? This is applicable only at 25 Celsius degree. So this is the difference between them for any temperature, but at 25 Celsius degree, KW takes this value. Good? Let's have another important sequence. Try to write this as in a sticky note here, okay? Here, look at this. As the temperature is increased, as what? Temperature is increased, ionization is increased. Ionization of H2O, of course. Self-ionization of water is increased. Once the ionization is increased, H3O is increased, OH is increased. So, therefore, KW is also increased. So KW at 25 Celsius degree equals to 1 times 10 to the power negative 14 at 25 Celsius degree. Okay, but at 30 Celsius degree, it must be greater than this. At 10 Celsius degree or 20 Celsius degree must be smaller than this. Okay, so what's the relation between the KW value and temperature? They're direct. They're direct. They're what? They're direct. Why? Because as the temperature is increased, ionization is increased, both concentrations are increased, therefore KW is increased. Okay? KW is always constant. This value stands for 25 Celsius degree. The ionization of water increases as the temperature. I say this, I'll explain. Okay, so let's have some important notes. Some important notes. Indian accent. Okay, look. KW equals to H3O times OH. This is true for any temperature. But with this value, it stands for 25 Celsius degree. In neutral medium, look at it, please. In neutral solution, H3O and OH, they're always equal. So if one of them is increased, the other one must also be increased. This time, look. Let me tell you something, please. Be careful with this. The concentration of H3O and OH, they are both directly proportional with the temperature. Okay? But mister, what if the temperature is constant? At constant temperature. Okay. First one. In neutral medium. If I increase H3O, so OH must be decreased. Good? If I increase H3O, OH is also increased. They're direct. Okay? Because they must be equal. Therefore, H3O equals to OH always. Okay? So in neutral medium, without changing temperature, look, first of all, with changing temperature, H3O and OH, they are directly proportional with the temperature. Okay? But what if the temperature is constant? At constant temperature, in neutral medium, If H3O is increased, OH must increase also, because always H3O and OH are equal. But in acidic medium, in acid or base, okay, H3O and OH, they're inverse. They're inverse. If I increase H3O, OH must decrease. If I decrease H3O, OH must increase. Good? That's all. بەردەوام. In acidic and basic H3O and OH, they're inversely proportional. Increasing temperature increases altogether H3O, OH, and KW. Good? In any aqueous solution, no matter if the solution is acidic or basic or neutral, the result of this multiplication is called KW. At 25, it has this value. Okay. That means any aqueous, it means water-based solution. No matter if it's acidic, basic, or neutral, all of them, they contain H3O and OH. But in acidic, H3O is greater than OH. In basic or in alkaline, OH is greater than H3O. And in neutral, they're equal. OH equals to H3O. You should know this. The point is, because we have prepared all the solutions, acids, bases, neutral, for in water, so all of them, they contain H3O and OH, but it depends on the type of medium, which concentration is greater. Which of the following factor influence the value of KW? It means what factor influences KW value? KW but state change the biagala but concentration OH and hydronium and what? Okay, the only factor that can affect KW is the temperature, and they are directly proportional. Be careful. Temperature. KW at 25 Celsius degree, you should know it must be smaller than this number. Smaller than this at 20 Celsius degree, I mean. KW at 30 greater than this. At 25 equals to this. Look at it, please. This rule is applicable for what temperature? Only this part that I highlighted, for any temperature. But with this value, this will be true only for 25 Celsius degree. How about this? This rule is true for what temperature? As I said, for any temperature, any aqueous medium. So all of them, for all of them, for all of them. Impure water, impure water. What is pure water? Neutral. Okay, in neutral, H3O and OH, they're directly proportional. Increasing temp. Okay, as the temperature is increased, OH is increased, H3O is increased, and KW increased. So all are increased together. Wait. OH and H3O are remain equally? Yeah, because it's neutral. So OH and H3O, they're always equal in neutral medium. This is also true. Self-ionization of water is increased? Yeah, ionization is increased, as I said. So all are correct, my dear. Share example. Bainalai, water ionization constant. So now what is water ionization constant? It's a constant value at constant temperature, calculated mathematically using this rule. KW equals to H3O times OH. This rule is used for any temperature, any aqueous medium. Good? Just wait. Let me have a sip of water. Okay. Now we have a very important scale for the hydronium ion, my dear. Try to have a white paper and اوی پێت دەڵێم لەگەڵ من بینووسە یان بۆ شێوازەی فێری بە زۆر بە ئاسانی فێری دەبی ئۆکەی تەماشاکە حیات تەماشاکە گیانی من تەماشاکە بابی من تەماشا. This is the concentration of the hydronium ion at 25 Celsius degree. The concentration of hydronium ion at 25 Celsius degree is ranged between 10 to 0 until 10 to negative 14. So in the middle, there must be the middle, let me count the middle here. It looks like middle here. 1 times 10 to the power negative 7. These numbers are in molar concentration. As I told you, the big bracket stands for the molarity. Good. So now let's complete the scale. 10 to negative 1, 10 to the power negative 2, 10 to the power negative 3, negative 4, negative 5, negative 6, 7, 10 to the power negative 8, 9, 10, 11, 12, 13. Okay. So H3O in any aqueous solution is ranged between that one 0 لبو 10 to the power negative 14. that one سالب 4. لأنه هذا إيش معناها 10 to negative 7. تماشاك جاني من لإستوى أو لميش خد دابنيها بلا مستر لا يتسبم بن حفتي يعني أو لا يتسبي حفتي أو لا تينا أو لا بيدلين acidic territory أو لا بيدلين acidic area acidic medium. This is for the acids أو لا تيا acids. How about this? It's for the bases. Bases. Okay. And here, neutral. Neutral. Very good. For the acid, the great majority will be for the hydronium ion. Okay. Let me say the acid, hydronium ion لو يقولتها. لبيسي OH لو يقولتها. لنeutrally يكسان بوي هردوشان. Okay. So in the acid, hydronium is greater than this. In the bases, hydroxide is greater than this. In neutral, both are equal to this number. Okay, in the acids, as I told you, which ion presents by greatest amount? H3O. So here, hydronium ion is greater than the 1 power 10 to negative 7 molar. So here, hydronium ion is greater than this. But here, hydroxide ion is greater than this. 1 times 10 to the power negative 7 molar. But how about here? Both are equal to this number. H3O equals to this number. And the OH also. 1 times 10. Okay, if you أو یک زرانه بنوسین نوسی هیچ موضوعی نگوره. حالا گوره خوی کت موضوع. Good. If H3O is greater than this, that means OH must be smaller. So OH is smaller than this. 10 to the power negative 7 molar. How about here? If OH is greater than this, so H3O must be smaller. H3O is smaller than this. Great. Let me repeat the whole points. In the acids, كاكلنا acids أيونك منظورة H3O. إذا لكاتم سر H3O لو يقولت لا acid. أجا H3O لو يقولت ربي OH لو يقيس كتربي. In the acids we have more hydronium, so hydronium is greater than this. That means OH must be smaller than this. In the bases we have more hydroxide, so OH is greater than this. That means H3O is smaller. But in neutral medium, both are the same, which is this. Okay? So, I will mark these or this part of the information as the first point. This is point number 1. Point number 1 is correct only at 25 Celsius degree. So these information are correct only at 25 Celsius degree. تنها 25 Celsius degree correct now. أنا لبيلينا كيف شبابي من? Okay. So now let's compare hydronium and hydroxide with each other. Look, which one must be greater? Of course, H3O here is greater than OH. But here, both are equal. And here, OH is greater than H3O. So this information, I will mark this as the second part. Okay, this is point number 2. Point number 2. Point number 2. Point number 2 is correct at any temperature, or I can say always. Always correct. So now we have 3 different questions. Which of the following is true? Which of the following is true only, look, only at 25 Celsius degree? This part number 1, this is only at 25 Celsius degree. Which of the following is correct at any temperature or always? Part number 2 will be correct. This is only at 25, this is always. Only and always. What if I say this is true at 25 without only? Okay, this is true at 25. Point number 1 is correct. And this is always true, including 25. So look, I'm going to repeat the 3 questions. If I say only at 25, only this part will be correct. Always true, only the second part is correct. At 25 without only, both are correct. At 25 without only, both are correct, because this is true at 25 and this is always true, including 25. Okay? But this is not only at 25, it takes all the temperatures. Okay? Okay, my dear? Yalla. So I explained Kridana. Asha. I'll get back to this. What about عندك بسياري حلقين زارية? Let's have some practice from here. Era. Okay. There. An aqueous solution of base. سيمانة ليرة base. Which of the following is true? Dalay Mr. For the base, for the basic solution, OH must be here. لبو basically OH must be inside of the mouth. Okay? For the basic solution, OH must be here. For the acidic solution, H3O must be here. H3O must be here. Easy? Good. Look. Which of the following in the aqueous solution of a base, which of the following is true? Base, it means OH must be inside of the mouth. Good. OH must be here. Now H3O is here. No. Mister, this one, OH is here. Yeah, correct. Just wait, please. OH is smaller than this? No. This is incorrect. H3O is this? No. Very easily. Mister, for the bases, OH must be here. For the acid, H3O must be here. Sanasam. Good? بەردەوام. Which of the following is a neutral? We don't need to have greater or smaller. We don't need this. For neutral, we need the equal sign with the correct number. Good? H3, no, we don't need these numbers, please. For the neutral, try to remove all the greater and smaller signs. Okay? Look, H3O equals to this. Yeah, correct. Which of the following is an acid? Look, acid. It means H3O must be here. Good. Tamam. H3O is here. Correct. How about this? 1 times 10 to negative 2 molar HCl. Look, this is acid. So once we have a formula of the compound, we don't need any more information to testify if the compound is acid or the base. We all know that HCl is an acid. HCl is acid. So we need nothing more. Even if we have HCl AQ, so this is acidic. We don't need any number. Dazani kaka HCl acid class. How about this? Acidic, but Mister, this is a weak acid. Correct. Chish malo weak and stronger. بسيارة قدر كامل من acid. هو acidic kaka acidic acid. خل acid. All are acid. Okay. What allowed some بسيارة. Question 6. It's true about the acids at 25 Celsius degree. Mister. The question didn't say it only at 25. If the question said only at 25, we will take the first part only. But at 25, we'll take both parts. First part and second part. Okay, for the acid, first of all, H3O must be here. Good. H3O is greater than this. Yup. This is only at 25. Good. But it's true at 25. The point is, H3O is greater than this is acid always at any temperature. How about this neutral? So both are correct because the question didn't say it only. So both will be correct. This is true at 25 and this is always true including 25. This is also correct. So both are correct. But if I change the question into which of the following is it's true about the acids only at 25, then we only take this. This is not only at 25. This is at any temperature. And this is always true. Which of the following is true about the acids always? Okay, this is always. Or only at 25, this is only. Good? Impure water at 25 Celsius. Okay, water is a neutral substance. Is neutral. Good, in neutral. That means we don't need the greater sign and the smaller sign. H3O equals to, oh my God. Okay, no problem. H3O equals, oh, let me remove this. Okay. So H3O is equals to this number in molarity, of course. Even though we don't have molarity. So this big bracket stands for the molarity. It's a symbol of molarity. It's also true. This one is also true. Look, this is always true at any temperature, and these two only at 25 because the question didn't say it only, so all are true. If I say only at 25, then A and C correct. This is impure water always, then B is correct. Good? I'm gonna leave these. This will be your homework. Look, in the aqueous solution of neutral, neutral, mister. Hydronium equals to this. No, hydronium equals to 1 times 10 to negative 7. Incorrect. Contains neither hydronium and hydroxide. Allah, we have hydronium and hydroxide in all aqueous solutions. This is incorrect. Has an equal numbers of hydronium and hydroxide ions. Yeah, true. None of them, no. C is correct. This is your homework. I think we have skipped something. This note. Okay, so to identify a given solution, if it's acid or base, always try to use the what? The concentration of the hydronium. If you want to know some given solution is acid or base, so try to use hydronium always. But if hydroxide is given, then convert it into the hydronium ion concentration. Then based on the scale, we will decide if it's acid or if it's base. Okay? So by the way, how to convert hydronium to hydroxide and vice versa. We have this rule, which is Kw. Kw equals to H3O times OH. And because all the questions are standing for 25 Celsius degree, therefore we always use this value as the value of Kw, because all the questions in the book will be for 25 Celsius degree. All the questions. Okay? Once the question didn't mention it, it means it's a room temperature, 25 Celsius degree. But if we have a question by something rather than 25 Celsius degree, then Kw must be given. Must be given because we don't know the numbers. We only know Kw value for 25 Celsius degree. So if we have some temperature rather than 25, then Kw must be given. Good. The first one. The first question. Identify each of the following solutions as acid, base, or neutral. First one, if H3O is this number, okay, based on the scale 10 to the power negative 0, 10 to the power negative 7, 10 to the power negative 14. Here we have acid, here base, and neutral here. 10 to the power negative 9 of H3O is located here. So this is a base. This is a base. How about this? Okay, so the number is located here. It's supposed to be acid. No. Who said this? جاوب سيد كاكا بيز أحمد. تكريبي ماملي. Wait. أجر OH مان هبو OH يبقى H3O. Then you can decide based on the power. But now we have OH. So how to turn OH into H3O? Use KW value. KW equals to H3O times OH. Okay, look. So H3O equals to KW over OH. KW over what? Over OH. Now will be H3O equals to, okay, 1 times 10 to the power negative 14 over oh, this is KW, of course. And OH equals to 4 times 10 to the power negative 3. So this one will become, I think this is 0.25 times 1 times 10 to the power negative 11. However, I'm not sure about this number, but most likely the correct. We just need the power to decide, okay? Negative 11 is located here, the basic area. So this is also a base. This is also a base. Yeah, the number is correct, fortunately. This is, so the solution is a base. Okay, بعده بسيارة شحال كان بابي من دي. The hydronium ion concentration in a solution is this. Sir, hydronium is given, correct. The power is located at the right side, so this is a base. How about this? The hydroxide ion. Hydroxide, it means OH equals to this. Wait. Convert this into H3O, then decide it. So H3O equals to KW over OH. KW is 1 times 10 to the power negative 14. OH is 1 times 10 to the power negative 11 will become 1 times 10 to the power negative 3 molar. This is acid. So this solution is acidic. And I think I have solved the rest of the other questions here. Very good. Cool. جماعة ديستا وآگاداربوون رجاءً لبو درسي دابي. Please, for the next lesson, try to review a list of these strong acids and strong bases. You will need them extremely. تاو كات بخواتان دسبيرم بخواتان.